Okay, we're going to look at two acid and base titration questions today. These are both in the textbook as well. So the very first one, what I do is I underline any of the important information as I read it. So it was found that 11.5 centimeters cubed, so that's the volume, of a 0.5 molar, that's the concentration, of sulfuric acid was neutralized. And even in a different colour, you can underline the basic substance, 25 centimeters cubed of a given solution of sodium hydroxide. Okay, and then also the equation is really important here, so we don't need to underline that, but it's just there to highlight it. So calculate the concentration of the sodium hydroxide. So I need to find the concentration, again the same colour of the 25 because that's to do with the base, in moles per litre and in grams per litre. So these questions to do with titration, so we often have an acid and a base, and we're missing usually a concentration of either the acid or the base. So what I do is we're going to use this formula, the molarity of the acid times the volume of the acid of the number of moles of the acid, and the exact same the other side but to do with the base. So before I do that, I'll just write on the side all of them down in a row to make sure I can use this formula before I head straight into it. So the molarity of the acid, we have in the question, it's 0.5. The volume is usually the average titer, so if you're doing an experiment, the volume is how much acid you titrated down into the conical flask full of your base. And the number to do with the acid, is the number in the equation. So if we look up here, we have to say that the H2SO4 right here is the acid and the NaOH is the base. So you see how there's a 2 in front of the NaOH? That's the number of moles, the ratio, that's linked with the sodium hydroxide, and there's no number in front of H2SO4, so we say that there's an imaginary 1 there. Okay, so Na, the number for the moles of acid to react, will be 1. Then the molarity of the base, we don't know. That's what it's asking us to find out in the question. The volume of the base is 25. And the number that's linked with the base is in the equation again. And you can see it is 2. There's a big 2 in front of the NaOH. So there we go. So seeing that we're only missing one of these variables, we can sub in all of them into the equation and we'll be able to figure out the molarity of the base. Okay, so then if you bring things over, this is going to be 0.5 times 11.5 divided by 1 is the same as just leaving it as is. I'm going to bring that 2, this 2 right here, across, and if it's divided by on this side of the equation, if we bring it over here, if we're going to bring it over here, it's going to be multiplying. Because our end goal is to try and isolate MB on its own. So I need to get everything away from MB, the molarity of the base. So I'm going to bring that 2 over. At the moment it's dividing as it's under the line. So the opposite to divide is multiply. So I'm going to write it in as multiply by. And then if I want to isolate the 25, right now it's multiplying. So if I bring it across, it's going to divide. If you put that into the calculator, then you'll get your molarity, NB, to be 0.46 m, which is your Mb. Now that's 0.46 molar, can be written as 0.46 moles per litre either. They are the exact same unit, they mean the exact same thing. So that's actually part A done. As you can see up here, it asks for the concentration moles per litre. That's it done. We need to convert to grams per litre now. And we're going to use this equation. The number of moles equals mass times the relative molecular mass. So we have sodium hydroxide is what we're dealing with. We're finding the concentration of it. So the relative molecular mass of that would be, in your periodic tables, 23 for sodium, 16 for oxygen, and 1 for hydrogen, which would give you a relative molecular mass of 40. So the number of moles is 0.46 mass over 40. Again, if we bring that 40 across, it's divided by under the line right now. So if you bring it across, it turns into a multiply. So it's going to be 0.46 times 40, and that'll give you your mass, which will be 18.4 grams per litre. So you have the concentration of the sodium hydroxide in moles per litre and also in grams per litre from doing that titration. Now let's take a look at the next one. We're going to use the exact same equation, but first of all, make sure you have everything. So list out Ma, Va, Na, Mb, Vb, Nb on the side and see if you have everything. Let's take a look first at it though. So it was found that 11.5 centimeters cubed of 0.5 sulfuric acid was neutralized by 25 centimeters cubed. Oh wait, that's the same one, sorry. I have a different one. Oh, here's our different one. Okay, we've got 2.5 grams of an impure sample of our sodium hydroxide this time, and it was dissolved up and made it into 250 centimeters cubed in a volumetric flask. So we have 25 centimeters cubed portions of the base, and then a different color for the acid, 0.5 molar H2SO4, and we have 3 different titers. So we've done the experiment 3 times, and we've gotten these numbers. Okay, so underline everything else to do with the base, 2.5 grams and 250 centimeters cubed. Okay, so something slightly different with this one is that we have 3 volumes for the acid. So we're just going to tackle that first. Look at the 3 of them. We first 17.1, 16.7 and 16.8. When you're doing titrations, you have to keep going until you get an accuracy of 0.1. So that means that those 2 values differ by only 0.1. And those 2 values are here. So what I'm going to do is I'm going to take the average of those 2 values, and we'll get 16.75 centimeters cubed. Okay, and that is going to be your volume for the acid used. So that was slightly different. So now let's look see if we can use this formula, and we have everything for it. This will always usually be the formula that you're going to use for these equations. Okay, so why don't you pause if you've gotten this far and try and figure out if you have everything. Okay, some of you might have filled in Na and Nb, which is great if you did, and some of you may not have. So this question, if it was a standalone question, you'll just have to create the equation yourself. So that's what I'm going to do here. So we have H2SO4 as our acid, and we have sodium hydroxide that we titrated against. Now an acid and a base come together to form a salt and a water. So I know that water is going to be on this side. So that takes out the H and an O there, okay? So let's see, if we just disregard the hydrogens and the oxygens for the moment, what else is left over? We have sodium and this sulfate ion here. Okay, so you should know that sodium is in group 1, and it usually forms ionic compounds which have turned sodium into Na+. So it's usually going to give away 1 electron. SO4 sulfate ion is a complex ion, and it usually has 2 minuses attached to it. So you see that there's an imbalance here between the charges. So I'm going to need another sodium to balance out those 2 minuses. So knowing those little facts about those ions and how they come together allows me to write down Na2 for the 2 Nas, SO4. Now I need to check if it's balanced. Okay. So we've got 2 Nas on the right hand side, so I need to put a 2 here. I have an S, 4 oxygens, and then just check if the water is okay. Okay, so the water needs another 2 as well, because we have 4 H's over here, and we only have 2 on this side, so I need to multiply this thing by 2. Now that is balanced. Now it's the same as the other question above it, as you see here, this equation right here. But that wasn't a separate question, so you might have to form your own balanced equation. But now I have Na, which is 1, and Nb, which is 2, and I'm left with this, the molarity of the base in the middle. So I can go ahead and fill in my equation up there. So I'm going to quickly pause and then fill it in. Okay, there we go. So again, my job is to isolate Mb. That's the only variable that I don't have. So I need to bring over these 2 over to the other side to isolate my Mb. So if I want to bring 2 across, at the moment it's being divided by, because it is under the line. So the opposite to divide is multiply. So if I bring that across, I'm going to multiply it into the left-hand side. Okay, and I can leave the 1 there as is, it's fine. And that leaves me with Mb times 25. Now if I want to bring the 25 across, at the moment it is multiplying. So if I bring it across, it's going to divide in. And then you can put that all in your calculator and you'll get the molarity of the base to be 0.201 molars. Or you could say 0.201 moles per litre. Now let's look at the question again. So it said calculate the percentage purity of the sample of caustic soda. So we weighed out 2.5 grams of it. So obviously all of that isn't pure. So we need to figure out, based on our concentration, how much of it is pure. So it was weighed out in grams. So I'm going to convert the moles per litre into grams per litre, so I can compare how much I've actually weighed out. Okay, so because we don't measure mass in moles, we measure it in the grams. So I'm going to change that into grams per litre. And to do that, we have this equation. So the number of moles was 0.201. We don't know the mass. The relative molecular mass is 40 from our periodic tables. And I can work out the mass there, which is 8.04 grams per litre is the mass of NaOH. Now that's in a litre. We didn't have a litre. They made it up into 250 centimetres cubed. There's 4 250s in a litre. So what I'm going to do is I'm going to take that 0.804 and divide it by 4 to see how many grams I would have into 50 centimetres cubed only. And I'll get 2.01 grams into 50. Okay, so the 0.804 is how much would be in a litre. The 2.01 grams is how much is in the 250 centimetres cubed. Now, I didn't weigh out 2.01, I weighed out 2.5. So there's a clear difference there. So if I compare the 2.01 grams, which is showing up in my titration, because that's the active ingredient in it, the rest of the substance that was weighed out isn't reacting with the acid. And I compare that to how much I've actually weighed out, which was the 2.5 grams. I'll work that out to be 0.804 as a decimal. So that's how they compare to each other. If I want it as a percentage purity, you just need to multiply it by 100. And you'll get 80.4%. So the NaOH was 80.4% pure. Active ingredients, the NaOH. The rest of the substance is not NaOH. Okay, that's it for the video.